In this video, I'll be going through the algebra content for the Foundation Maths paper for the OCR specification. So I've gone through the specification and picked out all of the content, as well as thinking about the kind of exam questions that you may get. The first area of this video is going to look at the algebraic terminology and proofs. So this is about understanding the certain vocabulary that you're expected to do. So there's expressions, equations, formulae, inequality, terms, and factors. Now factors will largely have been covered in number, but there is an algebra element to that as well when we look at later how to factorize. But expressions will not have an equal sign. It will be a collection of terms. There will be no equal sign with them. Equations you will be able to solve, so you'll be able to get an exact value for the given unknown. A formula, that is likely to have multiple unknowns in it, and it's going to link to something quite practical. So it's usually going to be something like the area of a circle. Inequalities will come up later in the video, but recognizing that we don't always have both sides equal, one side could be greater or less than the other. And then terms, which is going to be the individual components that make up usually an expression or an equation. What you do need to know is the differences between these. Some questions have been about linking the words to the correct algebra, so you want to make sure that you've got a rough idea of what they're going to look like, and some of these clues here that I've gone through will be able to give you that as well. The next bit is collecting like terms. This will come up a few times because it's not just a topic on its own. Questions can be quite nice at the start where you've got the same unknown in there. So like they've given 2a plus 3a, they both contain the unknown a. You can have multiple unknowns, and you can also have add and subtract in there. And so you need to make sure that you only collect together those terms which are going to include the same unknown. So collect your a's together, collect your b's together, and if there's some numbers, collect those together at the end. This next section looks at the idea of simplifying products and quotients. So when you multiply and divide, how do you actually collect that term together to write it in a simpler way? So when we multiply, this is usually going to create a power if we've got the same unknown being multiplied together. If you've got whole numbers at the front or integer values, they will multiply together as normal. If you're using different letters, they sort of squish together. You don't put the times sign in between them. There's some standard index laws which we did go through in the number video, but if you've not seen that, it's recognizing when you should add and when you should subtract those powers. And sometimes the divisions will look like fractions and you'll have to simplify from there. So this can be, again, easy questions near the start of a test, but it could also creep in a bit later and become a bit more complex or part of another problem. A very standard set of questions you'll find that will probably appear in the exams at some point is about being able to expand or multiply out brackets. So you want to be able to do that and then write your answer as simply as possible. Some of the examples here are showing that you may have two brackets being multiplied together, which is a bit more of the advanced area, or you might have two separate brackets within a given problem. So you may have to expand one bracket, expand another bracket, and then start collecting those like terms and writing it as simply as possible. Take very good care there with your negatives and positives, making sure that you use the rules of integers correctly and that you've collected things together as you can. Alongside expanding is going to be factorizing, so you want to make sure that you can write an expression with brackets by taking out the largest factors that you can. So an easy question would be to take out the largest number. A more challenging question could be where you'd also take out an unknown. So there's a second example there where they've taken x out as a factor. And you also want to be able to factorize quadratics, which will come up again a bit later. There's a couple of advanced ones on here, which is not normal for an exam. The first two, they can come up, but the last one there with square roots is less likely. So making sure you can do this. There are a few different methods you can use, particularly for expanding. So make sure that you are comfortable with that, particularly with two binomials where you've got the two brackets. Making sure you use FOIL or a grid method, something along those lines will help you a lot. In this next bit, it goes through formulating algebraic expressions, sometimes writing out a formula, being able to actually write that down. This I found is quite tricky for a lot of people, recognizing that they might actually have to put an unknown in there. They might have to say that something is x. And so there's been a few questions on this. Sometimes it involves ages as well. So someone's 2 years older than the other, and you've got to write down an expression for it. This then ties into a more complex problem. Now, recognizing this question can be difficult, and I've seen people also solve it using trial and improvement, which isn't as reliable and it can be more time consuming. But I'd say at a push, you'd probably do that. But you want to try and understand when you should be using an unknown, when it should be being multiplied, and when you should add. So the example they give here, the cost of car hire at £50 per day plus 10p per mile. So you've got different units there. As it's 10 pence per mile, you're going to multiply the 10p by the number of miles, and then at the end you're going to add that £50 once you've got the units sorted, and then you've got to use your unknowns correctly. So you probably use m for miles, and you'll probably use h for hire cost at the start, and then you'll have a total cost at the end. The next bit is making sure you substitute values correctly into an expression or an equation or formula, whatever it's going to be, and then being able to evaluate and figure out the value at the end. These are usually straightforward. You can see in the more complex example to the right that they've used decimals and negatives. That's likely to be in a calculator paper, and if you've got a calculator that allows you to display things fully, that will be quite straightforward. But you want to make sure that you understand when you should add, when you should multiply, and how BIDMAS will apply in those situations. This next bit looks at changing the subject of a formula where you'll have to rearrange. Now this is heavily dependent on you using inverse operations correctly and then knowing the correct order to do that. Later on there'll be a function machine part to this video which actually can help a lot of people get that order correctly. So in that middle column, the last bit, it says y equals 3x minus 2. So you've got to decide, will I divide by 3 because that's the inverse of the times 3, or will I add the 2 because that's the inverse of minus 2 first? Which of those do I do? The way I've taught this is that if you know what x is in this situation, the first thing I do is times 3, the last thing I do is minus 2. And when you do your inverses, you work back. So since the last thing was to minus 2, the first inverse is to add 2. These can take a bit of practice. If they appear near the start, they're going to be quite nice. If they appear near the end, you're likely to have to do 2 or 3 inverses in order to get that subject changed. The number of marks is usually quite reflective of that, and so you do need to just make sure you can have a go. Don't be afraid if you're not so sure. If you start showing your inverses, you may well get some marks and credit for it. You will need to recall standard formulae. So there's a few examples up here. In the shape work, I'd look at some of the specific formulae for finding areas of shapes, but it's giving examples there of like circles, Pythagoras, and trigonometry. You won't get given those ones. There's never been a paper I've seen where those are given. The only one I've ever really seen given is the one to do with pressure, force, and area. So they may give that, but they don't have to. You are expected to know these. Trigonometry is often recalled by various sort of methods, so SOHCAHTOA, and then there's these triangles which really are helpful because they will do a lot of the rearranging. In these situations, I have written on here about understanding the question. Quite a few times I see people, they'll see a triangle, they'll do Pythagoras. They've not really thought about if Pythagoras will help, they've just seen it and done it. So do look carefully and think, well, is this a question where I can use this? Will it help? Circumference and areas of circle, I've often seen people use the wrong one. So the question asks about circumference, they use the formula for area. So you need to know them and you need to know when to use them. What was introduced in the 9-to-1 GCSE were kinematic formulae, and these are typically given. You aren't necessarily expected to remember them. It does say use them. The problem here is understanding the letters and what they represent. So each unknown here represents some slightly different things, and that can usually put people off. Typically the ones are U, because that stands for initial velocity, and whereas the other ones are generally okay. So if an A is acceleration, that makes sense. It starts with the letter A, and T is time. That makes sense. But U does not make sense, and if they ask about S as displacement, that will be another one that you'd have to use. I've not seen many questions involving displacement. I have seen them usually involving the other formulae above. So those were added at new. You don't have to memorize them. You've just got to be able to substitute in and use them correctly. Solving linear equations, you may have to set up and solve, so you may actually be given something in words and you've got to create the equation and then solve it, or there could be a shape problem that it will have. But there are two general types. The first one, which is easier, is where you only have to really do a couple of inverses and your unknown will just be on one side. So in the example here, 3x minus 1 equals 5, you've just got the x on the left. The second type, which is a bit more challenging, is where the x's appear on both sides, and what you will need to do is your inverses to move the x's to one side, usually the left, and then your other terms to the right. You can see that there's brackets in that example. You would usually choose to expand those brackets first before you get started. You could have division going on and you may have to multiply. So again, consider your inverses and make sure you apply it to both sides consistently so that you are doing the same to both so that it will remain balanced all the way. Do expect your values of x to be negative decimal, and maybe you'll have to write them as a mixed number if that's helpful in a non-calculator paper. They don't always write these questions so that x works out to be a nice positive whole number. Be aware that they will put challenge in, particularly if it appears a bit later on in the paper, or if it appears in a calculator, one where you're expected to use the calculator effectively to get that answer. The next bit is solving a quadratic equation, and before you really even attempt this, you really need to make sure you can factorize a quadratic, because you need to do that before you can do this. And the idea of these sorts of questions is that once you've factorized, you then want to look at those two brackets that you'll have, and your answer will be the sort of opposite of what you can see. So if one of your brackets has x add 3, your solution for that is x equals negative 3. So you want to do that opposite. The other thing they've put in this bit here is to actually sort of create a more context problem when it talks about the area of a rectangle. That will be more challenging if that's right near the end, and that will take a little bit more work and some rearrangement. So that there is difficult. Again, I've seen people try that with trial and improvement. If you are factorizing and using this in a context, consider if your answer is going to be sensible. So when you have factorized, if you get a positive and negative answer, if you're dealing with the length of a side, you can't have a negative length for a side, so that answer is not the one you're after, you want the other one. It's quite rare as a question. Most of the ones I've seen are fairly standard, and they just say solve this, and it will appear near the end. Simultaneous equations is a fairly standard problem to get in an exam. It's nice if they do just put them there as two equations and say, here they are, go solve it. They don't always look like the example they've given here. Usually the x and y terms are both on the left, and you can go through a standard method called elimination to get rid of one of those unknowns and then work out the other. You will need practice on this, and again, do not expect solutions to be positive, negative and or decimal. That can happen in these, particularly as it will appear nearer the latter stages of a paper. It is possible you may have to form the simultaneous equations, so you may be given some practical information and you'll be given two sets of information to create a formula. So you want to use like x and y for various things. I think I remember one question where it was talking about, 2 portions of fish and 3 portions of chips cost this, and then you'll have 1 portion of chips and 5 fish and it costs this, and you have to then create that formula and solve it. The only good news about that is if you have to create it in practical terms, it's less likely to have negatives. So if that was about the cost of fish and chips, it's not going to be a negative cost. So you know what you're dealing with, and you can kind of get a sense of if your answer seems sensible at the end. There is another method called substitution that might be appropriate, but most exam questions I've seen don't do that. It is in theory possible to do this by a graph, but again, I haven't seen that many questions about the graphical methods in OCR papers. This next bit looks at how you might use graphs in order to find solutions. So one of the ways it wants you to do that is to be able to find the roots or approximate roots for a quadratic. Now this could be part of a question where you've drawn the quadratic, so you may have had to actually plot it out, and then the roots are where it goes through that x-axis, and there should usually be 2 of them. It is possible to be 1 or even none, but it usually will go through there and you will get 2. The other is to understand how you might draw or plot a linear equation, so a standard straight line graph, and then be able to use 2 of those and find where they intersect to get an approximate solution. So those graphs may not overlap a nice coordinate like this one does. It overlaps at 2, 3. It might be 2.2 and 4.1, and you are going to have to read carefully as best you can. Mark schemes do have a little bit of leeway for that, so as long as you are careful, you should be able to pick up marks there for reading that point. The next bit looks at inequalities and being able to solve those. It does talk about in one variable, so you've not got to worry about anything more than one. Understanding and using those symbols, so knowing your less than and greater than, and then your less than or equal, your greater than or equal, knowing what they will look like and how to read those, typically from left to right. You want to be able to solve them. You solve them using the exact same process as you would with an equation. It does not matter what that symbol is there. You would solve it by doing inverses. The next part might be to represent that on a number line. So there is this open circle and filled circle or solid circle, however it's been explained to you. And those represent whether it's going to be the less than or greater than, or whether it's going to include the equal to. The last type of inequality that is on here is where you've actually got two inequalities either side of your sort of expression in the middle. So in this case, we've got 3x minus 5 in the middle, and when you do your inverses, so you're going to add 5, you want to apply that to the left and the right, as well as to the middle, so that it actually removes them. And then your solution on the number line is going to have two circles at either end and a line connecting them. It is possible to have inequalities to solve where the unknown does appear on both sides, like an equation, so do be aware of that. It is also a case that you might have to write down something like possible integer solutions, so which whole numbers will work, and you have to then make a list of them. Functions I mentioned earlier, they can appear quite early on in an exam or a test because you might be expected to do some input-output work and in order to sort of figure out what's going on, but they are actually very useful in order to get the inverses correct if you have to do something like change the subject. So in this case, it's showing that you're going to times 2 then add 3, so when you do your inverses and you work back, you would subtract 3, divide by 2. So if you understand how a function machine works, you are going to be able to use that to your advantage in order to change the subject or be able to do inverse operations for other tasks. Sequences, generally the basics are that you would need to know how to identify a pattern and continue that pattern. Typically a sequence that increases or decreases by a positive amount. That's the kind of basics, and then later on it's about finding that nth term rule. Now the phrasing in exams are not always going to be find the nth term rule. It might be find an expression in terms of n. It doesn't necessarily have just one single way which it could be phrased. You will also need to be able to use that rule to generate sequences or find future terms. That will include sequences where it does contain n squareds. It's not going to be a case of just linear sequences all the time. There are other questions as well in exams where they will ask, is this number in the sequence? So you can set up an equation there to figure out if there is a whole value of n that will work. N has to be a whole number. It is the position of a number in a sequence. So if you get a decimal for your n, that means that number can't be in the sequence. It's not going to work. You do need to be aware of various special sequences. So there are examples like triangular numbers, square numbers, cube numbers. Those there are things which you should know about. The square and the cube numbers I've done in the number video, but triangular numbers are where you've got like 1, 3, 6, 10. It goes up like that. When you think of items that can be arranged in a triangle, I often think about like a set of pool balls and how they would be arranged in a triangle and how many are in there. That's an idea of where triangle numbers come from. The more advanced type are going to be Fibonacci, quadratic, and then geometric. Now Fibonacci is a sequence where you get the next term by adding the two previous ones, and I've included in here the most standard example, but those numbers don't have to start with 2 1s. It could be something else that it starts with, so you just have to make sure you use the rule. You also have to realize that some questions now do involve algebra, and so they might say that the first two numbers are a and b, and then you have to work with that. A quadratic sequence, and your squared numbers is a basic quadratic sequence, they will have a constant second difference. So if you find the difference between the numbers, you'll see it's not the same each time, but when you find the difference of those, that second difference, you'll find that is the same. And you can use that to work out future terms. You will not need to find the nth term rule for a quadratic sequence. A geometric sequence is where your term-to-term rule is going to involve multiplying or dividing. So this sequence I've given is the doubling sequence, and so that involves multiplying by 2, but be aware that will not always be a whole number, it may be something else, but as long as you're multiplying by that same value each time or dividing by the same value each time, you have got a geometric sequence. A very basic thing is knowing about your coordinates, your x and y coordinates. It has not changed since many of you have been taught this at primary school. It is the same thing all the time, along and then up. So make sure you do that. It's a silly mark to lose. The next part is making sure that you're able to plot and draw graphs. So using a table of values, they are mostly given and partially completed. But if you don't have that, then you've got to set one up and choose nice values for x before you start. You may have to work with the negatives, but if that's the case, start from the positive end of your table and work back, because you may start to see a pattern, particularly in the linear graph, that will make it easier to get those last points. Plot them carefully and draw a line appropriate. If it's a straight line graph, draw a straight line. If it's a curved graph, draw a curve. Do not join them up dot to dot. You want to make sure it is a perfectly smooth curve as best as you can do. So make sure you can do that. It can be quite nice marks for most people. If you get a point that seems to be wrong, it doesn't follow the pattern of the rest, it's probably wrong. So go back and check your working. One tip is that if you are working with negatives and you're going to square them or something, make sure you put the negative in bracket if you've got a calculator. Because if you square a number on a calculator and you haven't got that negative number in brackets, it is not going to return the answer you expected. So make sure you do that and check your points and see if they do seem sensible. If your graph's going all over the place, it's probably not done correctly. The next bit is to look at various more advanced graphs and being able to recognize and sketch them. So your y equals graphs are always horizontal, your x equals graphs are always vertical. You also have the diagonal lines. Y equals x is the common one, but y equals negative x is the diagonal that flows in the opposite direction from left to right. You will need to recognize how a cubic graph, a reciprocal graph, and a quadratic graph will look. And so there are some diagrams here of what they actually do look like. And as it mentions, it talks about finding the roots. So in which case it's understanding where those roots are graphically, but also how they link back to the algebra when you factorized. You do need to have an understanding of things like intercepts, being able to understand the symmetry where that appears in graphs like the U-shaped graph for quadratic, and the turning point, which is that usually that peak or that lowest point in that curved graph, and finding that coordinate. So the next bit we're going to look at is graphs in real world contexts. You will need to be able to construct and interpret those graphs. So have an understanding that the slope of the graph is the rate of change and the intercept is usually like a fixed start point. It could be a fixed cost. Some of these graphs, if they're directly proportional, are going to go through the origin. So money conversion is a good one, because if there's £0, that would be $0, for example. And as you go up in pounds, the amount of dollars will go up in a proportional way. It will go up in the same rate. You also need to know how the inverse proportion graph works. It's a curved graph and it will slope in this way. It looks like part of the reciprocal graph. And this is because if we take, for example, sort of like speed, distance, time, if you had an axis where the speed is getting faster and faster and faster, the time taken will get less and less and less, but you're not going to get to that point where the speed is so fast that the time is 0. You know it's going to get lower, but it's never going to actually get there. So that's why you have this sort of curved graph. You mostly have to be able to spot them rather than overly use them. This next and final part of my video looks at gradients. It will be worth mentioning intercepts as well, but gradients are this rate of change that you have on a straight line graph. And you do need to be able to calculate this gradient so that you are then able to determine the equation of a straight line graph. The standard method is to form a triangle between 2 points and look at the change you've got in your y-axis compared to your x-axis and do a division. It's not going to matter which 2 points you choose, just choose nice points that are landing on coordinates that you can easily read. This will then give you the gradient for the graph, and a standard graph is y equals mx plus c, where m is the gradient, so you want to be able to know that. You also want to know what an intercept is, and in this case it's mostly the y-intercept, so where that graph goes through the y-axis, and this will be the value you add or subtract at the end. Understanding that it's a rate of change is important, and that will be given in a context. So in a distance time graph, it talks about velocity. So if it's steeper, it's faster. If it's shallower, it's slower. You get a sense of how that might be interpreted in a practical context. Now that brings me to the end of the video, and I've gone through everything that is in the specification about algebra. With every question you do in an exam, make sure you have read it carefully and fully. There have been a number of mistakes by not doing so. There shall be questions on algebra which are going to be very short and direct. It's going to say do this, do this, do this. You do not have to then overly think. There will be other questions where it's harder to identify that algebra is in there. So read carefully, think about what's appropriate to apply, and then go for it. Okay, so thank you very much for listening, and hopefully this will give you an idea of some areas that you will want to look at further for revision in preparation for your exam.